Okay, so today we're going to be going over an MCP79 based board that does not turn on, and it is a problem that is not BGA related. So a lot of people like to think that this is a BGA problem, and one of the things that I try to do on this channel is I try to inform you, I try to teach you, and one of the things that I try to teach is that you should use your brain and have a proper understanding of how a circuit works instead of buying into this culture of just replacing things for no reason, reflowing things for no reason, heating things up in an oven for no reason. And the thing is, if you heat this, it will work again, but not for the reason that you think. And again, all those people on the internet that are telling you to do things because of the solder balls and those cheap lead-free solder balls, they're just, for the most part, they are just dumb. They don't know what they're talking about, and they're just giving away really shitty information. So as you can see, I'm plugging this thing in. I'm getting a green light in my charger. But when I short the pads, turn it on, it does not turn on. So one of the first things that I'm going to do, the thing that I tell all you guys to do when you have a board that has this type of issue, is you're going to go through your list of power rails and see which power rail is not present. So this is an 820-2610 motherboard, which, as I like to say, is an old piece of crap. So we're going to go through the list of power rails here, and I'm going to show you what's going on, how this works, so that you can hopefully learn something. I'm finally figuring out what Adobe doesn't like. When I use these shortcuts like Control 1, 2, and 3 for Open Broadcaster, this doesn't like when I use those in Adobe. It actually screws with something in Adobe. So I'm starting to figure out the things that make my videos wind up being a mess. Anyway, so let's go over to the 820-2610 board and start going through the power rails in the machine. So this is one of the older ones where you get this nice block diagram. On the newer Apple products, you don't get the block diagram. You get a middle finger. Now, let's see. Power rails is going to be getting close. Okay, so let's just start testing. We have PP Bus G3 hot. Let's see if I have PP Bus G3 hot. I'm going to take my multimeter probes. Plug them back in. And we're going to go over why this is, as always, a circuit problem, not a BGA problem. Because I'm cheating, by the way. I know what's wrong with this. I haven't measured this board. I have not measured it. It's just I've been fooled by it so many times. And recently I got fooled by it, even though I've done this so many times and got owned by it until this intelligent gentleman named Duke on a forum that I'm on pointed out why I was being an idiot. And I realized that I was missing something that I had done a million times before. I was actually heating a certain part of the board, and right under it was the point that was the issue. And I thought the thing that I was heating on the top was it, and it was just driving me nuts. And then when I actually wound up looking on the bottom of the board and I saw the position of it, I'm like, you motherfucker. But anyway, moving on. So this says on this board that PP Bus G3 hot is supposed to be 6 volts. I don't think that that is correct. Let's see. Yeah, on this board it's 8.3, so the schematic is wrong. I know that because I've measured this a million times. I know that my DC in rail is good. Again, there's no reason to measure the DC in rail when I have any type of rail in the machine working the way it's supposed to. I know the charger works. There's no reason to measure PP3V42, as I've mentioned in other videos. That is for the one-wire circuit. The one-wire circuit works off of PP3V42, which means that if I have a green light on my charger, the one-wire circuit works, which means PP3V42_G3 hot is working just fine. Now let's measure for PP5V_S3. That's the next rail, PP5V_S3. And I measure that, and when I measure that over here, let's see what I get. So on PP5VS3, I get 0 volts. Now, as I said, before you start trying to figure out if there's a problem with the chip or with the circuit, see if the chip is actually turning on. So let's scroll over to what creates PP5VS3. You can do it, PDF reader. Okay, so U7201. Now, as I've said a couple of times, look for enable pins or entry pins or something that tells this chip to turn on. So the enable on this is coming from P5VS3 enable, P5VS3_enable. That comes from PM Sleep S4L. Now, do you think PM Sleep S4L is going to be good on my board or bad? Let's measure. So that's where it shows up. When I measure PM sleep S4L, I get, let's see, it's right next to the fan connector on this probe point. Huh. That's not really a good place to measure. Let's try on the resistor above. I get 0 volts. Now let's see where PM sleep S4L comes from. For some reason it switched over to the microscope. Oh well. Anyway, just to go back over that in case it was missed. PP5V_S3 is created by U7201. The enable pin of that chip, it had the enable signal comes in through P5VS3_EN. I look for P5VS3EN to see where that came from. That comes from PM sleep S4L. Let's make sure Open Broadcaster didn't switch on me. It didn't. So now we look for where PM sleep S4L comes from. And we see that PM sleep S4L, which is going to be needed to enable PP5VS3, comes from our MCP79. And the MCP79 is also the graphics chip. So what the average person is going to think at this point is they're going to think that the signal that is missing comes from the graphics chip. The graphics chip burned out. I need to replace the graphics chip. I need to buy a new one, and I need to solder a new one on there. This needs BGA rework, right? Wrong. So let's go over what powers the MCP. So the MC, because there's a list of power rails here. And again, that's the thing. Like, I've solved this problem. And I got to a point where I had this problem, and I just said, let me just heat the BIOS chip first, because for some reason I just decided to be a monkey that day and do the same shit that everybody else does and heat the fucking BIOS chip, and it worked. And what you're going to see is right under the BIOS chip on this board is my problem spot. So, okay, so let's scroll over here and see if there's anything of interest to us. So here are certain rails. PP1V8, 1V5 SO MCP. Now, we're not in an SO state, so I'm not going to check an SO rail yet. PP1V05 SO MCP. Again, I'm not in an SO state. I'm in an S5 state. I'm off. I'm not really interested in that. PP1V05 S5 MCP. Okay, that's something I may want to check. That's something I may be interested in. So let's take a look for it. So that creates PP1V2R1V05_S5. So let's look for that. That's supposed to be 1.5 volts according to the schematic here. PP1V2R1V05_S5. So that's created from the U7750 chip. U7750 chip. Okay. So this is a buck converter. That's something that you should know if you watched any of my other videos. Now, let me explain to you the sheer amount of idiocy that I've... Seriously, why does this keep switching over? What key am I hitting on this keyboard to switch the camera over? Is it okay. Just since I don't know if you actually saw the stuff that I was looking at, I'm going to scroll back to it. I swear, I'm going to get a second monitor for Open Broadcaster so it stops trolling me. Is it when I zoom in and out in a PDF file that's doing it? Okay, so what I was looking for was a power rail for the MCP because I wanted to start checking all the lines. And what I see here is there's a bunch of SO rails, but then there's also an S5 rail, which is a rail that's supposed to be on that powers the MCP when the MCP itself is not, when the computer itself is off. So I searched, and I found that power rail, that S5 power rail, is provided by U7750. So that creates PP1V05_S5 MCP. This tells me that it is a 1.5 volt power rail that is supposed to be present on the MCP when the machine is in an S5 power state, meaning the machine itself is off. So if you see S5, that's a power state that should be present when the machine is off. S3, that's a power state that should be there when the machine is sleeping. SO, that's a power state that should be there when the machine is on. So let's measure that. Let's measure that along L7770. And what I'm going to do over here is I'm going to go over all the stupid shit that I've done to learn what I've learned. Okay, so when we measure over here, that's supposed to be 1.05 volts. And when I measure on that inductor, what I get is going to be, let's see if I can put the multimeter where you can see it. Who am I kidding? That's almost invisible. There. Oh, well. You'll just have to trust me when I read the voltage then, I suppose. It shouldn't be that hard. So when I measure on that inductor, what do I get but 0.317 volts. Let's see if I can hold this here. See how good my chopsticks are. See that? That's not 1.05 volts. So let's talk a little bit about what could be going on here. So what most people are going to do is they're going to think that the MCP is bad and it's bringing the line down. And they're going to replace the MCP. Or they're going to reflow it. And well, you know what's really, really sad here? The sad thing is that it's actually going to work again. And they're going to think that it's because the MCP had bad solder balls. They're going to think it's because the MCP had some kind of, maybe you just reflow the inside of the chip. Whatever silly theory you have as to why that made it work again, people are going to believe it. Now, what I thought, I already know that's bullshit. But I believe it or not, at one point I tried it and it worked, and then it died again, and I didn't know why. What other people are going to think is that this power supply here is not working, or one of these transistors is bad, or this controller is bad. Something here is not working. They're going to drive themselves absolutely batshit insane going through this circuit on the screen over here, trying to figure out what doesn't work. And they're going to think it's something over here. Now, what I want you to think about is this. What component in this circuit is going to be affected by heat? Think about what the makeups are of these components. An inductor is a coil. This chip here is just a bunch of integrated circuits of transistors and resistors, whatnot inside of it. These are just resistors. The one part of the circuit, which one of the components in the circuit is known for its intermittent nature? It's going to be a capacitor. A capacitor is known as a part that can sometimes work, sometimes not. Sometimes work, sometimes not. Sometimes work, sometimes not. So I was heating this thing, and it would work again, and then it would die. In the beginning, I really honestly thought that maybe it was the MCP. Later on, I realized that it had to be something else. And again, I was so close at one point in time, even after having replaced this stupid little capacitor at least 10 times, that I have a whole fucking spool of them here. I was so close to actually replacing the BIOS chip again that I just didn't get it. Like, I replaced the BIOS chip, and it worked, and then it died. I heated the BIOS chip, it worked, and then it died. I put another one on there, it worked, and then it died. So on this board, right here is the BIOS chip, right? On the other side of the board is the capacitor. So let me show you the capacitor that goes bad. The capacitor that goes bad over here is C7771. And one of the hints that I should have had, one of the hints that really should have brought this out to me based on my history with recording consoles, is the fact that this capacitor is made of tantalum. So I can't zoom in because the PDF reader is being a piece of crap, unfortunately. But right over here, you see this? Where it says polytant? Tantalum is a miserable, miserable type of capacitor for one reason to me, and I have some really bad memories attached to it. Tantalum can actually make you sick. So when a tantalum capacitor explodes, like some of the tantalum capacitors that they have in these old consoles, when the capacitor itself explodes, you can get a good 102 fever over the course of just a few hours from being in the room to inhale that shit. So I know that I hate tantalum. I have a natural hatred for capacitors that are made of tantalum. And one of the things that you'll notice about tantalum capacitors, and one of the reasons they get used, is they're pretty small compared to any other type of capacitor. So this is the tantalum capacitor right over here. It doesn't look bad at all, and I should have known this. So what I do is I replace it with a standard polymer capacitor instead of a tantalum capacitor. You can replace it with many different types. I just chose the 330 microfarad capacitor, rated for the same 2 volts. And here's the thing, the problem. This. So I have to get a way for this to fit in here. And that is going to suck. But we're going to find a way to get this to fit in here, because this will provide a good option. This is actually going to work. It just, again, it takes a lot of finagling and bullshit, which we're going to be going over, and then we're going to see if this actually works when it's done. Now, one of the things I wanted to put the camera back on so you could see, I was actually going to take it off for this because I was going to have the other person here help scrape away the pads, is that somebody else at some point in time figured out this problem, because watch what's going to happen when I use my hot air station. You see how there's liquid flowing away? That's flux. So that means that somebody else at some point in time probably refurbished this board, because the flux is right around the component that I said always goes bad. And what they did, that we're not going to do, is they reused the fucking tantalum capacitor that I said that you're not supposed to use. So they probably took another tantalum capacitor off of another shit board and put that tantalum capacitor here, and it died again. Again, so you may think that this is silly that I'm going to be using a different capacitor than the one that was intended, But I'm using a different one because I have a fundamental disdain and hatred for tantalum. And as silly as it may seem, it is well founded on the fact that these things have made me sick. Not only have they made me sick, but they also caused the board to stop working. So, I'm going to heat this thing. Takes a lot of heat to get this damn thing off. Now, here there's no reason to remember orientation. The reason I don't care about the orientation of the chip, of the capacitor, is because the capacitor that I'm installing is not a polarized capacitor. If you're installing a capacitor that's polarized, you have to worry about the orientation of the chip. But when you're installing a capacitor that's not polarized, you have nothing to worry about. Here, it is completely acceptable for this specific application that we don't care if we're using a polarized or a non-polarized capacitor. Either one will work fine. Again, the only trouble here is going to be how do you fit that in there when there is no space. So the first thing I'm going to do is tin the pads so that I can properly remove all of the solder and all the junk on there so we can get it nice and flat. And then we can start scraping along on both sides. And just so you know, a capacitor is a component that when you heat it, you can actually get it close back to the original value and get it working the way it was again. That's not necessarily true for every type of component, but it is true for a capacitor. All right, so that's replaced. So let's just get a little look at what that looks like under the microscope. I haven't cleaned it off the board yet. I can't tell you that this is the nicest looking thing in the world, but what I can tell you is that most likely will work. So let's just find where what I did is, and that is, yeah, that's this pile right here. So that's the capacitor. There we go. Yeah, so that's that. That's the new enlarged capacitor, and I moved the coil up because the inductor was actually keeping that from working. So Jess always says it's not the coil. Sometimes it actually is the coil. The coil is in the way of my new capacitor fitting. So let's see what we get now. I'm going to take my DCN board. And again, a lot of people think that they heat that component. After they heat the component, it works. It's because when you're not heating the MCP, you're heating the capacitor next to the MCP, and you're making that cap work again for a short period of time. So let's see what we get. Before we had 0.3 volts. Now we get... Milan says we get poof. This is his board, so hopefully we don't get poof. 1.09. We're supposed to get 1.05. 1.09 I will certainly settle for, because that's good enough. And so when you see these voltages in the schematic, one of the things you need to understand is that there's tolerances. So if you see 5 volts and you measure 4.999, that doesn't mean you need to start troubleshooting that rail. That means that you need to start going on to what the actual problem is. So I'm going to short the pad, see if it turns on. And as you can see, my fan spins, which here is the ultimate test that the board works and that no further testing is required. Send back to customer. I'm kidding, but you get the point here. So this was the repair. And I'm going to wind up doing a video on this on BGA rework in general, because I feel like a lot of people jump to BGA rework just to kind of make the excuse for themselves that they can't fix it when it's not a BGA problem. This board does have BGA problems. It has an LVDS MUX chip that goes bad. By the way, this chip goes bad 10 times more often than the GPU does, and it is a complete bitch to work on. But these boards do have BGA problems, but they're not the BGA problems that you think. A lot of people get caught up in this idea of replacing BGA chipsets when the BGA chipsets are not the actual chipsets that are at fault. It's power going to them. It's signals going in and out of them. And I'm trying to get you out of that culture, that mindset of just being a monkey that replaces chips for no reason, without thinking, without looking, without, I don't want you to be like me, heating who being somebody who actually went through this already over the course of several years, who's heating the fucking BIOS chip because he's just being an idiot.